Hello, buddy. Today we're going to continue the lecture series on how to learn mathematics. Before we begin, however, I'd like to remind you of something. There is no idea that you cannot learn. Just as there are laws of nature, there are laws of learning. The laws of nature do not discriminate. Whether you're black, white, Latino, Asian, a woman, it really does not matter. If you jump from an elevated position, you're going to learn on the ground. Similarly, if you follow the laws of learning, you will learn. With that, let's begin the dance here. So we're talking about how to learn mathematical ideas, how to collect mathematical knowledge. And we're learning techniques. And a very powerful technique I'd like to describe today is something I call do it badly. Do it badly. So our society and even in the education system, we're always taught that you have to do things correctly. You have to do them right the first time. And somehow doing things badly is bad. Right? I actually disagree with this. And it turns out doing things badly is actually a powerful mathematical principle. And so let's explore that. Suppose I have a box. You're going to have to forgive my artistic gifts here, huh? If you can call them gifts at all, right? So we have a box, and let's say we have a kid. I'm gonna call him Little Jimmy because the name just appeals to me, some weird reason, right? So we have a kid, Little Jimmy. Little Jimmy is a newborn. What does this mean? He's very confused. Has no idea what a box is, has no idea what empty space is. And let's say we tell him, Jimmy, touch the box. It's going to be like, what, are you nuts? What is a box? What is empty space? Completely confused. And being the naughty kid that he is, he decides, well, why don't I explore? So he touches there, and he touches there, and he touches here, and there, and there, and touches the edge of the box, and suddenly hits like, oh, right, here is the box. It's like, oh my god, that's what it means to be a box. Interesting. Well, what just happened here? Well, what happened was that little Jimmy first of all figured out what empty space is, and then figured out what it means for something to be a box. That is, he used what is not a box to figure out what a box is. And then now you're probably wondering, Christian, come on, this is too abstract. Sounds like philosophy. Let's do some math. How is this going to help me learn mathematics? All right, let's get to that. I'm going to start with this. I'm going to deal with a simple example because our point here is not to do complex mathematics, but to learn how to learn mathematics. So let's say I ask you this question, right? Give me the same number. When I multiply it by itself, I get 4. Well, you probably already know how to do this, right? For example, 2 times 2 works because 2 times 2 is 4. Minus 2 times minus 2 works because minus 2 times minus 2 equals to 4. But then let's suppose that you had no idea how to do this. This was like a genuine notion of source of confusion for you. What number, you have no idea what number to put in here, and you've been thinking for, let's say, 3 or 4 minutes, and you're now stuck. You have no idea what to do. Well, might I suggest doing it badly? So think about what number would be such a bad guess. Let's do it badly. So after a few seconds, you think, whoa, how about 100? 100 times 100 is 10,000. You're like, yes, this is definitely very far away from 4. So as far as guesses go, this is a really bad guess. So you think to yourself, well, can I make another bad guess, but slightly better than this one? So you say, sure. How about 50? 50 times 50 gives me 2,500. Like, wow, interesting. 2,500 is definitely not 4, but it's a better guess than before because it's much closer. So you think, oh, well, maybe I'm going to try something like 5. How about 5 times 5? Then you say, wow, that gives me 25. Like, 25 is not 4, but it's much closer. You're like, oh my god, I see. It seems that the smaller the number I pick, the closer I get to getting a 4. So like, how about if I try 1 then? I think this is going to work. Well, 1 times 1 equals to 1. So it seems like I went below. Then you think to yourself, oh, finally, inspiration hits. Well, how about 2? 2 times 2 equals to 4. Right? Let me erase this. I've just made a... Right. You figure out that 2 times 2... Where's my eraser? Right. We figure out that 2 times 2 equals to 4. And suddenly now inspiration has struck. You finally got it right. Well, let's think about what happened here. You figured out what definitely does not work. This does not work, and this does not work, and this does not work, and this does not work. And then you figured out what works. And you went in degrees of badness. You got something that was really bad, and bad but not as bad as before, and then slightly bad, and finally you got it right. This is the principle of variation. It's really how the brain works sometimes. And I'm afraid you might think this is trivial, which it is not. Right? And the principle is just, in order to, for example, know that little Jimmy is short, it means that you know what it means to be big Jimmy. To know that something is a circle, you need to know what it means not to be a circle. To know that something is small, you need to know what it means to be big. If you identify someone as drunk, then it means you also know what it means to be sober. If you say that something is right, to find out something is right, it also means you need to know when something is not right. Right? If something is incorrect, to know that something is correct, you need to know that it's incorrect, right? And this is kind of the same principle here. To figure out what the correct solution is, the correct method, what the correct answer is, or what the correct meaning of something is, try figuring out first what is not a correct meaning. Well, let's bring this home with another example. You probably already done prime numbers before. And your professor or your teacher probably gave you a definition in elementary school of a prime number. Probably said something like, a prime number is any number. Let me erase this again. I'm getting too excited here. Right? Calm down, Christian. Right? It's any number. A prime number, they told you probably, is any number that is divisible only by itself and 1. Right? Probably taught you this definition. And let's suppose that you're seeing this definition for the first time, and I'm asking you to write down an example of a prime number. Right? Write down a prime number for me. And somehow this is really confusing to you. You spend, let's say, 5 minutes, and you still can't think of a prime number. And you spend another 10 minutes, right? Tick-tock, time ticking. 10 minutes, nothing. Right? And you're wondering what to do. Well, right? Perhaps try doing it badly. Forget about trying to get an example of a correct prime number. Just get something that's definitely not a prime number. You think for a few seconds and like, 100. You're like, yes, 100 equals to 2 times 50. Definitely not a prime number because 100 is divisible by 2. Like, well, how about 50? Well, yes, this is also another bad guess because 50 is the same as 2 times 25. So you say to yourself, all right. And maybe you try one more example. You say 25. You're like, 25 is the same as 5 times 5. This is another bad guess, right? It's 25 is definitely not a prime number. But now you have a lot of data of what it means not to be a prime number. And suddenly maybe you can make a guess and be like, I wonder, how about 5? Well, the only thing that divides 5 is, only thing that divides 5 divides 5 and 1 divides 5. But nothing else does, right? And you're like, oh wow, interesting. So 5 is actually an example of a prime number. Once again, you used what is wrong, what a prime number is not, to figure out what a prime number is. And so this principle right here could really help you a lot. In fact, how do you know when to apply this principle of do it badly? Well, the best cue for it, as I've discovered, is you have some concept. Let's say you have an idea. Suppose you have an idea that is, let's say, it's supposed to be correct, or you're looking for a correct idea, right? This is your thing. You're looking for a correct idea, but you really can't find this correct idea, and you've been thinking for a while and you can't find a correct idea. Well, this is a cue that perhaps you should try to do it badly. Think of an incorrect idea and do a couple of incorrect ideas so you can generate variations for what's wrong. And in so doing, you might find that it's easier to find what's correct. And obviously the reverse works too, right? So to bring everything home, in order to know what's short, you need to know what's tall. In order to know what's a circle, you need to know what's not a circle. If you want to know that something is infinite, then you need to know what it means to be finite. If you want to know when something is correct, you need to know when something is incorrect. The principle of doing it badly. Like every other powerful principle, it seems trivial, but consistent application of it will literally work miracles for you. Well, this is really the end of my video. Thank you for staying. And if you did enjoy it, please subscribe below so that when another video comes up, well, you'll be informed about it. And in particular, no doubt there are probably things I said here that were incorrect, or perhaps my exposition was not good enough, or perhaps the video was not done correctly. Please let me know about this and be as harsh as possible in your comments. Right? That way I can improve this video in subsequent videos, so that together we can ensure that anybody who needs to learn how to learn mathematics will have it available in the best form possible. Thank you very much, and hope to see you on the next video.